Okay, so hello. Okay, so it's working now. So we want to go do this one, transient partial curve. Okay, so this is actually just an equation. This you can write in another form. This is same thing as this, like this, x equal xt. Describes a spatial curve that changes with time. If time changes by delta t, the coordinate have to increase by delta xi to meet. So you take a total derivative, I would say. This is a total derivative. Because this is constant. This is constant. So total derivative is something like this. Partial f, partial x dx, yeah, plus partial f partial t dt. This is 0. This is total derivative. So you just change this one to delta x, this one to delta t. So you obtain this one. So total derivative is 0. Dividing by delta t and take the limit, we find this is, I don't know. So then this part become uh, partial derivative, not total derivative. Yeah. It's how do you understand this? At any instance, this gives the rate of change of the coordinates of a point on this curve. Rate of change of the coordinates of a point. Partial f partial dt dx dt. This is not v. This is not v. This is not v. So v was like this, dx dt, right? I think so. So this was a velocity of a particle. Am I right? V was a velocity of particle. Yeah, this was v. This is for given x. This is for given x. X means a particle, the name of particle. So this is a velocity of particle, right? So, but this is not velocity. This is not velocity of particle. Is it strange? Equations of the form describe a spatial curve that changes with time. Spatial curve. spatial curve that changes with time. This is not spatial point. This is more like spatial point that change with time. The or the position of particle that change with time. But this thing describes a spatial curve that changes with time. So, okay, is this x actually a x vector? So this is more like f x y z t equals 0. I'm not so sure about it. Spatial curve. I'm not so sure. In two-dimensional, it's okay. If you have two-dimensional and f x y equals 0. Okay, this gives a curve. This is curve, but to me, for three-dimensional, this is a surface. I think x, y, z equals 0. This is a surface. Then if you have another parameter t, this is a surface which change with time. Yeah. So then equation of the whole describes spatial curved surface. Not so sure. So spatial curve that change with time. Dividing by delta t and taking the limit, we have this. At any instance, this gives the rate of change of the coordinate of a point on this curve. If it is a material curve, this rate of change will be the velocity of the material particle. Okay, now this says this is actually a velocity. If it is a material curve, that this rate of change will be the velocity of the material particle. From this, we get the Lagrange criterion criterion for special curve to be material curve. Okay, let's move on to the example. Okay, example. Path line, streamline, and streak line. Consider the plane motion given by the equation. x1, small x1 goes like large x1 cos t, large x2 sin t. Small x2 equal large x1 sin t plus large x2 cos t. Obtain the path line of a particle that was at the point 0, 1 at time t equals 0 using t equals 0 and x1 equals 0, x2 equals 1 equation 624. We find x1 equals 0, x2 equals 1. The equation for the path line, see figure 6.2, has the parametric form. X1 is which represents the hyperbola. X2 is 1. Okay, this is hyperbola. Path line is hyperbola. T equals 0. So this point is x. Because x is the position at t equals 0. So this particle moves like this for positive t and negative t. So this is path line. Obtain the streamlines through 0.1 at t equals 0. From equation 624, the velocity components are x1 sin t, v1 is x1 sin t, x2 cos t, v2 is x1 cos t, x2 sin t. Eliminating x1, x2 by using equation 624, we obtain v1 is x2, v2 is x1. How do you eliminate? x1 x1, x2. How do you do this? Okay, let me see. Let me try. Let's multiply since. Since TV2. Okay, I can do this. Since 2v2. And here I have to do cos t v1. So we have cos t here equal x1 sinh t cos t plus xt sinh t square, right? So you just minus cos t minus v1 minus sinh t v2 equal, this one is cancel, cos square t minus sinh, this is x2 minus sinh square t x2, yeah, and this is 1, I think this is 1. This is x2. So this is x2. So this is x2 you can put here, for example. So then you can obtain x1. So you can obtain x1, x2. Then maybe you can use the first equation, because now you know x1, x2. So then finally you get this. Is it difficult to solve? This is a big exercise. I think it's a big exercise. Maybe I should do it on my note. Let me give you a second. So I will try to do this to work out